Okay, folks. Gonna run through corrections from work I expected you to do last night. I'd asked you to do question 2, 4, 6, and 8. So I've got corrections on the screen here, and I'm just going to run through what's expected in a couple of them because a few people are asking questions about them just to clarify, and then hopefully you'll be able to do them without too many issues in for future reference. Okay, so question 2 was asking, it was giving you a group of different numerical sequences, and it was asking you to find the first term, T1. It was asking you to find the common difference, and I was asking you to figure out what the next three terms are. So I've given a couple of examples here from the question. I think there was 10 in the whole question, so I just plucked out 5 from that 10 to show you what's happening. So the first one there is 2, 6, 10, and it's asking you to continue on. Okay, so the first term in the sequence, very simply, is 2, because that was the first number that was given to us. The common difference is the difference between each term. So in a numerical or an arithmetic sequence, we have the same difference between each term. So we're going from 2 to 6 to 10, and as I can show you there in part B that's given to you, okay, you can see that if I do 10 minus 6, it gives me 4. If I do 6 minus 2, it gives me 4. Or I can do 2 plus 4 to give me 6 plus 4 to give me 10. So I can see that the common difference in this arithmetic sequence is plus 4. Now I'm urging you to put in the sign with this, plus 4, okay? Because some of them are going to be negative and you don't want to get mixed up. So plus 4 is the common difference in this case. And in the next three terms, how do I go from there? I use my common difference and I use the latest term that's given to me. So the term that was given to me is 10. That's the third term. I want to figure out term 4, term 5, term 6, and all I got to do is use my common difference. So I'm adding 4 each time. So I got 10 and I add 4. That gives me the next term, 14. I do it again to get 18. I do it again to get 22. So I can see that that's the case in each of these. All right, so that's the process, and we're just going to look at a few of the rest of the sequences that were given there. So I picked out these ones because they do different things. First and foremost, part 4 there, I've got I've got 100, then 90, then 80. I picked this one because it's the number's going down. So my common difference is actually negative in this case. You can see that the first term is 100, and then B, the common difference is minus 10 because I'm going from 100 to 90, minus 10, 90 to 80, minus 10. So that's my common difference. So I can continue on that sequence nice and simply, 70, 60, 50, and so on. Part 6, minus 5, minus 3, minus 1. So I'll pick this one because it's a negative value that we're starting off with. So my first term is minus 5. What's happening? To go from minus 5 to minus 3 to minus 1, I'm actually adding 2 each time. So my common difference is plus 2 in this case. And the reason I wanted to pick this one, I showed this one to you specifically, is because you know when I go minus 5, I add 2 to go to minus 3, I add another 2 to go to minus 1, the next term is going to be positive. It's going to be plus 1. Because I'm going from minus 1, I'm adding 2 to that. So this sequence goes from negative values to positive values. And you can imagine that in part 4, if I continued with my sequence, because it's going 70, 60, 50, 40, 30, 20, 10, if I kept doing that, I'd end up with negative values. Okay, so I just wanted to show you that one too. Part 7 there is a decimal sequence, so nice and simple as well. I'm going up in 0.5s, so I'm adding 0.5 each time. So my start point is 5.5. My common difference is 0.5 because it's going up. I'm adding a half each time, whatever way you want to think about it or look at it. And then the next three terms, 7, 7.5, 8. Nice and simple. Now, part 10 was a tricky one, I thought, and you had to look at it in 2 different ways, okay? So what we can see is what I wanted to show you here. I've got my terms in my sequence, 1/6, 1/3, 1/2. So the first term is 1/6, that's fine. Okay, now the way to do it for me is that I want to make the denominator the same. So what I did is I wrote each term in terms of something over 6. So I found the equivalent fraction of 1/3. I found the equivalent fraction of 1/2 in terms of sixths. and then you can see much simpler what's going on. So I've changed that. I've got 1 over 6, 2 over 6, 3 over 6. So you can see that the common difference then is I'm adding a sixth each time. Now that's not strictly obvious when you look at the terms at the very start of the question, but if you change those fractions around, then it makes it a lot more straightforward. So to continue that process on, part C, I can see the ones in the brackets are the simplest ones, I suppose. If I'm going 1 over 6, 2 over 6, 3 over 6, 4 over 6, 5 over 6, 6 over 6. And what I did then is I just put them back into kind of their most simplest form, I suppose. 4 over 6 has been changed to 2 over 3. 5 over 6 is in its simplest form, and 6 over 6 is 1. And then if I was to continue that on, it would be 7 over 6, 8 over 6, etc., etc. So that's question 2. And again, hopefully you'll be able to fill in the gaps and correct the other ones that you've done based on that guidance. Question 4, then I want to look at the question that's given to us. We're given a graph, and the points in red on the graph represent the term number and the term value, so a coordinate. We're asked to find the first term, the common difference, and the fourth term. Now all of the info is given to us in this graph, so all we got to do is write down which is which. Okay, so the term numbers are on the x-axis, or a horizontal axis at the bottom, and the term values are on the y-axis, or the vertical axis on the left hand side. So they're the numbers that I'm most interested in, really. Okay, so the first term, we can see term number 1 is 1. Okay, so the first term is 1. My common difference is going to be the difference between term 1 and term 2 and term 3 and term 4. So you can see, as I said, the term values there. Okay, so term 1 is 1. The term values are 1, 6, 11, 16, 21. I read those from the graph and I wrote them down, so we can see what's happening to those terms. I'm adding 5 each time. All right, and then the last part of question 4 asked me what was term 4, and it's 16. All right, so it's nice and simple. Last bit then, I wanted to run through question 6, so we'll just give a quick look at what the question gave us, and then we'll go back and we'll look at answers generated. Question 8 is very similar to this, so I didn't do that one as well, so I just wanted to correct this one and show you how it's going. So it says the first 3 terms of the pattern are shown. We can see what's happening. We've got a central dot, and I've got 3 dots around that, 1 on the left, 1 on the top, 1 on the right, and then in the next pattern I'm adding 1 to each of those 3 branches coming off the middle, if you want to think about it like that. So then I've got 2 on the left, 2 at the top, 2 on the right, 3 on the left, 3 on the top, 3 on the right. It asks to draw the next 2 terms of the pattern. So next 2 terms of the pattern, nice and simple. I've got my central dot, as I've shown you, and I've got 4 on the left, 4 up to the top, and 4 to the right. Term 5, same idea. Central dot, 5 on the left, 5 up, 5 on the right. So that's nice and straightforward. The question then asked, count the number of dots in each of the first 5 terms and display the results in a table. So a table, nice and straightforward. I've got my term number and I've got the number of dots in each term. So term 1 had 4 dots, term 2 had 7, and so on and so on and so on. And you can see that I've just filled it in nice and simple. So you can do that whatever way you want, but I'll draw that table. I would suggest using a ruler, unlike I did, but there you go. So that's all there is to it. As I said, just make sure you've got your term, and you can see I've put the name on the column at the very top, and that's quite important, just to represent what you're actually talking about. The terms are on the left and the number of dots are on the right. Part 3 then. Question says, describe the sequence of numbers generated by the pattern. So I'm going to use this table to figure that out. Okay, you can see what the table says. It's going up 4, 7, 10, 13, 16. And you can see that I've drawn it on the right hand side of the table. I'm adding 3 each time. Now, I can define a numerical sequence as arithmetic if the first difference is a constant, if the terms go up by the same amount each time. And this is what's happening here. My first difference is a constant. I'm adding 3 each time. So I can describe this as an arithmetic sequence. Finally, question 6, part 4. It says, how many dots are there in the 9th term? Okay, so there's loads of different ways you could do this. You could just keep drawing them and so on and whatever else. But I did it mathematically, and this is going to help us out now later down the line when we start using what's known as the general term. Okay, but we're not just there yet. So what I've done is I've broken it down into what's actually happening. So I've got 1. Okay, a 1 is representing the center dot. If you look at term 4 there, the big blue dot in the middle, that's the center dot. Okay, I've got the plus. Okay, so I'm adding 3 times 9 in my formula here. So 3 is the groups of dots. Remember, I've got a group on the left, a group on the right, and a group in the middle. So it's 3 times whatever number of dots are in each group. Term 4, there's 4 dots in each group. 4 on the left, 4 at the top, 4 on the right. Term 5, there's 5 dots in each group. 5 on the left, 5 at the top, 5 at the right. So in term 9, there's going to be 9 dots in each group. 9 on the left, 9 on the top, 9 on the right. So that's where I've come up with this formula. I've got 1 for the center, plus 3 is the number of groups multiplied by how many dots are going to be in each group. So it's 1 plus 3 times 9, giving me 28. So that's how many dots. There'll be 28 dots in term 9 of the sequence. Now, I hope you'll be able to use that to answer question 8. And we're going to move on today to look at a few others. Thank you very much.